Hey there guys, back for video 2 here. We're going to take a look at y equals x minus x squared and y equals 0. We're going to revolve that around y equals 2. So again, let's take a look at our shape here. X minus x squared, what we know about that shape is it makes a parabola. One way in which we can learn a lot more about it is if we just factored it to x times 1 minus x. We could see in that situation that it's going to cross the x-axis at 0 and at 1. And it's downward because you have a negative x squared. So going through 0 and 1 just like that. Bring you just a little bit closer here. Okay, great. All right, so I want to revolve it around y equals 2. I want to revolve it around y equals 2. So this is just a little bit different. We're going to go up to 2, and I'm going to take this section, that area, and we're going to revolve it around this line. Well, when you revolve it around that line, it's going up, and I'll show you the kind of the shape that you get. If we flip this up over the line, that's the new shape we're going to get. I'll put my my little rectangle in there, and I'm just going to try to draw this so you can see what happens. Again, that's your inside that gets cut out, and then this is your outside here. So that's my washer. That's a little bit awkward looking because I drew it backwards from how you saw it before. This time the washer's kind of tilted this way. Usually we like to tilt them that way. I tilted it this way for you so you see that edge and then that edge. But that's my washer, okay? And we learned that in order to calculate the volume of a washer, we do pi times big R squared minus little r squared. And we look at the thickness of that original rectangle that you drew, the thickness of the original rectangle. The original rectangle here has thickness of dx. So therefore, it's pi times big R squared minus little r squared dx. Let's investigate and see what that big R value is. My marker here is running a little bit low. Helps you store markers upside down. That way the ink drains and they stay nice and dry. My guess is that one of my children were playing April Fool's jokes on me and store them up and then drew something on the board this morning. Who would do that? So they forgot April Fool's Day yesterday. So I'm recording this on Thursday. They forgot April Fool's Day yesterday, so they want today to be a makeup day for April Fool's Day. So we'll see what happens around the house. All right, so let's get back here. This inner part here is my little radius. Notice how I'm drawing it down here this time. That's because that's where your original area was, okay? And then this is my bigger radius, okay? That smaller radius is this distance right there. What is that distance? That little radius is 2 minus my function, x minus x squared. That's this distance right here, top minus bottom, okay? Top minus bottom. That's how we come up with distance. So that's my little r value. What's my big R value? My big R value is the distance from here down to here, which is 2. Works out quite well. So therefore, as we set up the integral, we have pi times big R squared will be 4 minus little r, or 2 minus x plus x squared dx. And we don't want just 1 washer, we want an infinite number, so we slap on that integral. We look at our original area, which was down here, and we are looking for x values for that original area, so we're going from 0 to 1. 0 to 1, okay? All right, let's multiply that out. Pi times the integral 0 to 1 of 4 minus parentheses. If I multiply this all out, I'm going to have to kind of use some space up here. I've got x squared minus x plus 2 times x squared minus x plus 2. We're going to multiply that out. I get x to the 4th minus x cubed plus 2x squared. So I just finished that guy. Minus x cubed plus x squared minus 2x. Done with that guy. Plus 2x squared minus 2x plus 4. Done with that guy. So we'll combine like terms. I've got an x to the 4th. It's gone. Got a negative x to the 3rd and a negative x to the 3rd. Make negative 2x to the 3rd. Gone. I've got a 2x squared. I've got an x squared. And I've got a 2x squared. That makes 5x squared. Got a negative 2x and a negative 2x. It makes a negative 4x. I've got a plus 4. I know it looks really bad. The problem actually isn't that bad at all. And part of the reason is, number one, the 4's canceled here. So those are gone. We're going to distribute our negative through. In order to create a little bit of space here, I'm going to now move these parts away. This becomes pi times the integral from 0 to 1 of negative x to the 4th. And we have a plus 2x cubed. We have a minus 5x squared. And we have a plus 4x. So, antiderivative of negative x to the 4th is negative x to the 5th over 5. Antiderivative of 2x cubed is 2x to the 4th over 4, or x to the 4th over 2, 5x cubed over 3, plus 2x squared. Evaluated at 1 and at 0. So I have pi times negative 1/5 plus a half minus 5/3 plus 2. I like to create common denominators. Common denominator here I'm going to make is between 5, 2, and 3. We're going to make 30. So pi times negative 6 over 30 plus 15 over 30 minus 50 over 30 plus 60 over 30. 60 and negative 50 make 10, plus 15 is 25. 25 minus 6 is 19. 19 pi over 30. Yeah, that's a lot of work. The first video, you were revolving it right around the x-axis. In this video, you are revolving it around something different than the x-axis. And when you do that, you have to do that top minus bottom approach to figure out exactly what your radius is. I know it's not easy. Again, please reach out if you need some help. So I just have 3 problems for you for this section, and then all 3 problems for the other one. We're going to do dy. So we're just going to, nothing really changes other than the fact that it's a horizontal revolution as opposed to a vertical revolution. I think washers are the most challenging for people to work through and visualize. I think the cylindrical shells piece you see next week, it's going to make a lot of sense to you. You're going to like it. But I can see where this part can be challenging. Again, don't be afraid to reach out. We can do a video together. And then just know that I looked up all the information at the different colleges. I checked University of Minnesota, University of Wisconsin, a lot of different places. I just saw what are they making sure that they cover in their calculus classes in order to make sure that people are ready to go for their calculus 2. And without a doubt, people are still choosing to cover these topics, it seems, for the most part. After we get done with this one, we go back to our antiderivatives idea or substitution, which you've seen before. And so definitely trying to scale back some of the rigor of our material. I know it doesn't seem that way. It seems like it's really challenging. I'm doing my best. I know you guys are doing your best. Let's just work together and get it figured out. So anyway, thanks. Good to see you. We'll see you on the next video. Have a good one.